Hello students, welcome to Study Hive. In this video we are going to discuss about chapter 3 metals and non-metals. The concepts which I discuss here are what are elements, their classification, what are metals, their physical properties, what are non-metals and their physical properties. Let us start with the elements. The pure substances which cannot be further broken into simpler substances. The elements are classified into metals and non-metals and metalloids. You are not going to study this one in this class, but you are going to study in your higher classes like 12th standard. Okay. So let us learn what are metals. It is an element which forms cations by losing electrons. So metals always lose electrons and they form a cation. What are cations? Cation is a positively charged radical. Let us see one example, that is magnesium. It loses 2 electrons to form a positively charged cation, that is Mg2+. So what are the physical properties of metals? Metals are usually hard. The hardness of the metals varies from metal to metal, but there are some exceptions like sodium and potassium are very soft. They can be cut using a knife. Next property is malleability. So the property of the metal which allows them to be beaten into thin sheets is called malleability. So gold and silver are highly malleable. So this property of the metals allows us to design beautiful ornaments. The next property is ductility. It is a property of the metals to be drawn into a long thin wire. So you will be amazed to know that 1 gram of gold can be drawn into 2 kilometers of wire. Next property is most of the metals are solid in state. The exception is mercury, that is Hg, which is liquid in the room temperature. They are good conductors of heat and electricity. The exceptions are mercury and lead, Pb. They are bad conductors of heat and electricity. The next property is they have very high melting point. That is, they don't melt in a lower temperatures. That's why we use metallic vessels to cook. The next property is they are very lustrous. The luster means they are very shiny. And sonorous is they produce sound when they are striken. So the metallic wires are used in the violin. And the metal is used for preparing bells because they produce sound on hitting. So these are 2 examples. The next thing what we are studying is about the non-metals. The elements that lack metallic attributes, that is attribute means the quality or the properties. The elements that lack in a metallic attributes or properties, they usually accept the electrons. But metals used to lose the electrons and they form negative ion. They usually accept the electrons and forms negative ions. So what are metallic attributes? The sonoricity, lustrous properties, conductivity of heat and electricity. These are some of the metallic attributes. But these non-metals will lack in those. They don't have that metallic properties. That's why they are classified under non-metals. So what they do, they usually accept the electrons and they form a negative ion, that is anion. Some examples for the non-metals are carbon, oxygen and hydrogen. Let us learn the physical properties of non-metals. They are poor conductors of heat and electricity. The only exception is graphite. What is graphite? Graphite is made up of carbon. It is an allotrope of carbon. What are allotropes? Allotropes are elements. They can exist in the elements can exist in different forms. Each form is called an allotrope. Example is diamond and graphite both are made up of carbon. So carbon stays in 2 different forms. That is, one is diamond and also graphite. So these 2 are said to be the allotropes of carbon. The next property is they are present in the gaseous state and some are in the solid state. Exception is bromine, which is liquid. They are non-ductile, that is they cannot be made into wires. They are not malleable. They are very brittle. They break when we apply the pressure. So they are not lustrous. They are not very shiny, but the only exception is iodine, which is shiny. So this was end of this class. In next class we are going to study the chemical properties of metals and non-metals. So we are going to discuss how does the metals reacts with oxygen, how does it reacts with water, how does it reacts with acids and solutions of other metal salts, and also how does it reacts with non-metals. These 5 things we are going to discuss. Please listen carefully and focus on the examples and the equations I am giving for each of them. Let us start with the first one. Reaction of metals with the oxygen. So how does the metals reacts with the oxygen? The metal reacts with the oxygen to form metal oxide. You can see here metal reacts with oxygen to form metal oxide. We have done one of this activity which focuses on reaction of oxygen and metals, that is burning of magnesium ribbon. What happened there? Magnesium ribbon got burnt and it formed a white powdery substance which was collected in a china dish, and that was magnesium oxide. So what had happened there? Metal, that is magnesium, reacted with oxygen and it formed metal oxide, that is magnesium oxide. So let us see some of the examples other than that. Copper reacts with oxygen to form copper oxide. Aluminum reacts with oxygen to form aluminum oxide. So let us see what are the properties of this metal oxides. What are the properties of this metal oxides? These metal oxides are basic in nature. Where we have studied that metal oxides are basic in nature, we have studied this in the acids and bases. When they react with the acids, they form salt and water. These two are neutral substances. So this reaction tells us that the metal oxides are basic in nature. The next property of metal oxides is they are insoluble in water, and some of them are soluble in water, which they are called as alkalis. So some of them are soluble in water and they form alkalis. For example, see, sodium oxide reacts with water to form sodium hydroxide. This sodium hydroxide is alkali. So next thing what we are going to study is all these metals, whatever reacts with the oxygen, does not show the same reactivity towards the oxygen. All metal shows different kind of reactivity with the oxygen, different type of affinity towards the oxygen. Some are highly reactive. They are potassium and sodium. When they are kept open in the air, they react and they react very vigorously. That's why they are kept always immersed in a mineral oil or in the kerosene. So this is the frequently asked questions that in the previous years. So why potassium and sodium are kept immersed in the kerosene? This is the frequently asked question on this concept. Some of the metals like magnesium, aluminum, zinc, lead, etc., they react with the oxygen and form a thin layer like this on the surface of the metal. You can see that I have drawn 2 layers. One is this pinkish layer of metal oxide. Another one is inside, that is metal layer. So what happens when they form metal oxide? They becomes protective and does not allow the inside metal to react with the oxygen which is there here. Oxygen will be present in the air everywhere, but this metal oxide becomes protective in nature and it protects the inner layers of the metals against the reaction with the oxygen. They become protective. So hence we need not have to take any of the precautions to prevent oxidation of these metals. The oxidized layer itself takes care of that. So this is also one of the important question which is asked many a times. So next one is metal oxides are basic in nature. We have already studied this. That is some of the example for, let us take aluminum oxide. When it reacts with hydrochloric acid, it forms aluminum chloride and water. So it forms salt and water. That's why it is basic in nature. Metal oxides are insoluble. Some of the metal oxides dissolve to form alkalis. So let us see what are alkalis. Alkalis are basic salts. They are basic in nature which dissolves in water. When the metal oxide reacts with water, it forms metal hydroxide. So next reaction what we are studying is reaction of metals with water. How does they react with water? When the metal reacts with water, they form metal oxide plus hydrogen gas is released. Let us see. Potassium reacts with water to form KOH, potassium hydroxide, hydrogen gas is released and heat energy is released. Whenever there is a release of heat energy, we say that kind of reaction as exothermic reactions. Let us see another one example. Calcium reacts with water to form calcium hydroxide and hydrogen gas. Next one is aluminum reacts with water to form aluminum oxide and hydrogen gas is released. So what is the difference between these three types of three metals? See, potassium, calcium and aluminum. Let us take three examples. Potassium is highly reactive. That's why it can react with even the cold water. Calcium is moderately reactive. It comes under the moderate reactive metals. So it can react with the hot water. But when we come to aluminum and iron, what happens? They react with the steam. They comes under the below moderately reactive metals. They are very less reactive. They have very less affinity towards water. That's why they don't react. So we will study about the reactivity series later on. Let us see how the metals reacts with the acid. Whenever the metal reacts with the acids, they form salt and hydrogen gas is released. We have already discussed this in chapter 2, that is acids and bases, and we have also seen how to identify, how to do a conformation test for hydrogen. Please, if you have not watched this lesson, please, I'll give the link in the description box. Please watch that video also. Okay, next we are discussing reaction of the metals with solutions of other metal salts. So let us take two metal salts, metal salts solution of B. So here the metal will be B, here the metal will be A. Let us assume that metal A is more reactive than metal B. So what happens? The displacement reaction takes place here. So metal A being more reactive, it displaces the metal B from its compound and it forms salt solution of B and metal B is separated. Okay, for this you have to refer any of the displacement reactions. You will be able to understand that. So reactive metals will displace less reactive metal. So B being very least reactive when compared to metal A, that's why it get displaced here. So for that you have to understand the reactivity series. To know which is more reactive and which is less reactive, you have to study reactivity series. So I have already explained this one in the previous chapter, that is acids and bases and also chemical reaction. Both the times I have explained, but still I am going to do it once again for you. So I am giving one easy trick to remember, that is PSC Mazel hardly could make solid gold perfectly. This is a mnemonic to remember reactivity series of the metals. See, P stands for potassium, S stands for sodium, C for calcium, M for magnesium, A for aluminium, zinc for Z, I for iron, L for lead. See, again from this we have to take the first letter. We have to consider only the first letter like this. So H stands for hydrogen, C stands for copper, M stands for mercury, S stands for silver, gold, platinum. So when we move from here to here, from potassium to platinum, the reactivity goes on decreasing. So potassium are highly reactive and platinum is least reactive. So these which comes in the middle are moderately reactive. So hope this reactivity was clear. If you learn this reactivity series, you will be able to decide which metal is stronger, highly reactive, and which displaces which metal. So highly reactive metal always displaces the least reactive metal. See, for example, potassium will not be displaced by platinum or gold or silver. But if it is silver nitrate, like a silver salt, it will be displaced by any of the metal which comes above this. Above silver, whichever the metal comes, it can be easily displaced. The silver can be easily displaced. When it comes to calcium, calcium cannot displace sodium because sodium is more reactive than calcium. Calcium can displace magnesium because magnesium is comparatively less reactive when compared to calcium. Next one, we are going to discuss reaction of metals with non-metals. So we know what are metals and what are non-metals. So let us learn how both of them react. So metals form ionic bonds with non-metals and they form ionic compounds. So what are ionic compounds? What are ions? Positive or negatively charged atoms are known as ions. So ionic compounds are made up of ions. Ionic compounds are made up of ions. So let us see how does the ionic bond is formed. Ionic bond is formed by complete transfer of electrons. Complete transfer of electrons makes the ionic bond. When we come for the covalent bond, we always see that sharing of the electrons is seen. We will learn about covalent bonds in the carbon and its compounds chapter in the further lessons. Okay, so let us focus on ionic bonds now. Ionic bond is formed by complete transfer of electron. Let us take the example of sodium chloride. Sodium has 2, 8, 1, that is totally it has 11 electrons. Electronic configuration is 2, 8, 1. So one electron is extra here. If it loses one electron, it reaches octet. Its outermost shell will be fulfilled, that is it has 8 electrons, that's why it becomes happy. Okay, so it loses one electron. Next, what about chlorine? Chlorine gains one electron because see the chlorine configuration, the electronic configuration of chlorine will be 2, 8, 7 because total number of electrons in the chlorine is 17. So what happens in the last shell, it has only 7 electrons. So for reaching octet number, it has to gain another 1 electron. So 1 electron will be added to it to make an octet. See, the 1 electron, where does this 1 electron comes from? Electron comes from the sodium. So sodium gives out 1 electron. See, sodium gives 1 electron and it transfers it to a chlorine, and chlorine gains 1 electron, it becomes octet. See, Na becomes Na plus, Cl becomes, see here, Na, Cl, they both react, Na plus and Cl minus. Okay. Let us take another one example. So atomic number of magnesium is 12. So we can write the electronic configuration as 2, 8, 2, and 2 electrons are excess here. There are 2 extra electrons. So what it has to do? It has to lose 2 electrons to gain octet. So what happens in the chlorine? Chlorine has total number of electrons, that is atomic number will be 17. So how do you write the electronic configuration? 2, 8, 7. So in here it has only 7 electrons, it needs 1 more electrons. So this 1 electron will be given to each of the atoms. There will be 2 atoms of chlorine. So 2 atoms of chlorine. So each gets 1 electron from here. See, it gets 1 electron from here and it also gets 1 electron from here, and 1 electrons will be added here. So how does it change? Mg2 plus, that is it is losing 2 electrons. It is losing 2 electrons to reach the octet level, and also 2 MgCl2. Okay. So hope this is clear. We have studied the ionic. Let us see the properties of ionic compounds. The first is physical properties or physical nature. They are usually solid and they are strong. They are brittle in nature. So this property is seen? Why they are solid? Because they have a very strong force of attraction between the ions. Let us take the example of sodium chloride. Sodium ion and chlorine ions together make sodium chloride. Na plus and Cl minus, they do have a very strong force of attraction between the ions. So they are solid in state. Next is melting and boiling point. They usually have a very high boiling and melting point because the force of attraction is very high. It needs a lot of energy to break the bond. That's why we have to supply large amount of heat. So the melting point and the boiling point will be very high. What about the solubility? They are soluble in water and also other solvents like kerosene, petrol, etc. Whether they conduct electricity or not? Yes, when they are in the aqueous solution, they conduct electricity. Let us do one activity for that. We have taken salt solution in a beaker when we have kept 2 electrodes here and we have connected a bulb, a battery and a switch. So if bulb starts to glow, we have to understand that the salt solution, there is no wire between these 2 electrodes. When this salt solution conducts electricity, we have to understand that the ionic compounds will conduct the electricity. If bulb will not glow, what we have to understand, this salt solution is not conducting electricity. That's why bulb is not glowing. So whenever we turn on the switch, the bulb starts to glow. We have seen here. So why does it happens? Because let us take the example of sodium chloride again here also. They split into Na plus and Cl minus. Na plus and Cl minus. So these ions helps to carry the electrons from this electrode to this electrode. Passing of electrons always creates the electricity, helps to carry the pass the electricity from this electrode to this electrode. So by this we have to understand that ionic compounds in a aqueous solution are capable of conducting electricity. But what happens when they are in solid state? They are not able to conduct electricity because they are not in a ionic form. Only ions are capable of conducting electricity. See, in sodium chloride it is not in the ionic form, that's why it is not able to conduct the electricity in the solid state. So this was the end of this session. If you have liked this, we have written the list of metals. You can see here how I have written them. I have written based on their reactivity. These first set of metals are highly reactive. They are highly reactive. This first set is highly reactive. And the second set is moderately reactive metals. And third one is very less reactive, and they can be considered as least reactive among all the metals. So what we are going to do for the separation or isolation of these metals? How do we separate them from their ores? We use a special process called electrolysis. You have come across this process in the previous chapters. So what happens in the electrolysis we will learn later. As they make a very strong between all the elements which are there in the free state, we have to break the bond. That's why we are passing the electricity to break the bond here. The next one is using the reducing agents. What are the reducing agents we use for reducing these metals? We use carbon as a reducing agent. As they are moderately reactive, they make a very weak bond as compared to these metals. So we can reduce them easily using carbon. We use usually carbon monoxide or coke as the carbon form. Next is this silver and gold and platinum. These are mostly found in their free state. They do not react with other elements in the atmosphere like oxygen, nitrogen, hydrogen. That's why they are found in the free state. So it is easy for us to separate these metals from their ores. Next, before going for the extraction of the metals, we will learn few terminologies and definitions with regard to the metallurgy. See, first what I have written here, ores. Minerals from which the metals can be easily and profitably extracted are called ores. What is mining? Extraction of minerals from the earth crust is called mining. What is gangue? The unwanted impurities present in the ore are called gangue. What are minerals? Naturally occurring elements or compounds in the earth crust are called minerals. Next we shall learn how the metals are extracted from their ores. It involves 3 steps. The first one is enrichment, second one is extraction, and the third one will be refining. So what are the steps involved in extraction of the metals? First one is enrichment, extraction and refining. So what we do in the enrichment or concentrating of the ores, we wash off all the impurities on the ores. So there are so many impurities like soil, sand, etc. which are attached to the ores. We have to wash off all these impurities. These impurities are commonly called as gangue. These impurities which are attached to the ores are commonly called as gangue. So there are so many physical and chemical based on their physical and chemical properties of the gangue, it is separated. For example, magnetic separation is used when the gangue is attracted by the magnet. So next step is, let us see how do we extract different metals. Different methods are used for different kinds of metals based on their reactivity. Highly reactive metals like potassium, sodium, magnesium and aluminum, they are never found in their free state. So what we do with them? They are either found as sulfides or carbonates. So we use the method called electrolysis for them. Why do we use electrolysis? Because they do form a very strong bond. It is very hard for us to break the bond by using only the reducing agents. Reducing agents cannot be used here because they do form a very strong bond. That's why we use electrolysis. Let us see how do we do the electrolysis process in the extraction of the sodium. So I have drawn a very simple diagram for you which contains one container, and in that we have filled with the molten sodium chloride, and we are passing the electricity using a battery. When we switch on the battery, when we close the key, what happens? The electricity starts to flow. Then what happens? The electrolytic decomposition occurs in this container. So it will split the sodium chloride into Na plus and Cl minus, Na plus and Cl minus on passing of electricity. So sodium, that is Na plus, is a cation which has positive charge. Chlorine, that is Cl minus, has chlorine ion, Cl minus has negative charge. It is called as cation, anion. So there are two types of radicals, positive and negative. So we have two electrodes which is called, one is called as cathode, another one is called anode. Cathode will be having negative charge, anode will be having positive charge. Always anion moves towards the anode whereas cation moves towards the cathode. You can see that NaCl splits into Na plus and Cl minus. Na plus moves towards the cathode and Cl minus moves towards the anode. That's why you see release of chlorine gas near the anodes. If you have any doubts regarding electrolysis, I can do a separate video on this concept. Please don't hesitate to comment in the comment box. Students, next let us learn how the metals in the middle of the reactivity series, that the metals which are moderately reactive are separated. They are either found as carbonates or sulfide. For the sulfide ores, we do roasting. It is a special process which is done for the sulfide ores, and for the carbonates we use calcination. Let us see what is calcination and what is roasting. After both of these calcination and roasting, we get the oxides of that ore. After calcination of the carbonate ores, we get the oxide of that ore. After roasting of a sulfide ores, we get oxide of that ore. See what we are doing? Zinc carbonate, we are heating it in the limited air. So calcination is heating the ores in the limited air to convert it into oxides. What is roasting? Sulfide ores are converted into oxides by heating with the excess of air. So here we are supplying with the ample amount of air, whereas we are limiting the air here. We are limiting the oxygen supply here. So see, I have given the example zinc carbonate. When the air is limit, we heat it and it gets converted into zinc oxide and carbon dioxide is released. So what is happening here? Zinc sulfide. We do roasting for the sulfide ores. When zinc sulfide is heated with a lot of air, that is a lot of oxygen is supplied, then it gets converted into zinc oxide and sulfur dioxide gas is released. So after roasting, we got oxides of both the metals. You can see zinc oxide is obtained here and here. After obtaining oxides of the metal, we use reduction of the metal using either coke or carbon monoxide as reducing agent. We reduce them and we obtain the pure metal. After obtaining the metal, we also have to undergo a special process called refining of the metal. That is used for purification of the metal. Students, let us see how the least reactive metals, that are the metals which are in the lowest in the reactivity series, are obtained. See, they are usually found in their free state because they are not very reactive. That's why they are found in the free state. But some of them are found as sulfides. See, for example, mercury sulfide is there. So when we heat it with the passing of a lot of air, we get mercuric oxide. This oxide is again heated to get the mercury in the free state. So this is what happens in isolation or obtaining of mercury from their ores. But most of the cases like platinum, silver, gold are found in their free state. Just we have to concentrate or we have to purify the ore. We have to remove all the impurities from them. So next step in the extraction of the metals is refining. Refining involves further purification of the metals by removing all the impurities present in it. So we are going to study only the electrolytic refining of metals, but there are also so many refining methods like zone refining, vapor phase refining, chromatographic methods, etc. You are going to learn all these things in your 12th standard, but in this 10th standard we are going to learn only the electrolytic refining. See what the setup here is. A big beaker is container is taken. We are doing refining of copper. So what anode is used as a impure metal. After doing concentrating and extracting whatever the metal we got, we use here as a anode. So the impure metal after extracting is used as the anode. So pure metal that is pure copper strip is used as a cathode. When we pass the electricity, what happens? The liquid here is acidified copper sulfate. Any of the salt solution of the same metal has to be taken as the solution here. So we are acidifying it to increase the conductivity. What is happening? The pure metal will get attracted towards the cathode. This is positively charged radical. This is cation. That's why it is moving towards the cathode. This is cation, positively charged. That's why it is moving towards the negatively charged cathode. So what happens? All the impurities start settling down near the anode. That's why this is called anode mud. So what is the setup here? We have a big container with anode as the impure metal and cathode as a pure metal. Whenever we pass the electricity, the pure metal goes and starts depositing on the cathode and the impure metal starts settling down near the anode. That's why it is called anode mud. Students, this was the end of extraction of the metals. In the next class, we are going to discuss about corrosion and how. Hello students, welcome to Study Hive. In this video we are going to discuss about corrosion, rusting of iron and ways to prevent the corrosion. So let us understand what is corrosion first. The metals reacts with other elements in the surroundings and they get converted into oxides, sulfides and carbonates. See, these oxides, sulfides and carbonates are more stabler compared to their pure forms. Pure metals are less stable when compared to their oxide, sulfides and carbonates. So they always tend to convert themselves into more stabler forms. That's why they react with the oxygen, sulfur, carbon dioxide, etc. and converts themselves into oxides, sulfides and carbonates. But this deteriorates the quality of the metal. That's why it is harmful. The corrosion is harmful to us. Some of the examples of the corrosion in our daily life are silver reacts with sulfur in the air and turns black. Copper reacts with the moist carbon dioxide in the air and gains green coat. Iron, when exposed to moist air, forms the brown flaky substance. This is called rusting of iron. So we will focus on rusting of iron because iron is the most widely used metal. So rusting of iron, when iron reacts with moist air, it forms a brownish powdery flaky substance is called rust. So let us see what are the conditions required for rusting of iron. So I have taken three test tubes here. In the two I have added little bit water and I have taken 2 iron nails. So in the first test tube A, we have added water and we have immersed 2 iron nails in it and there is presence of air here. So we have both air and water. In the test tube B, we have added water and we have added a thin layer of oil here. And also there is air, but air is not directly in contact with the nails because there is a presence of thin layer of oil which prevents the air entering into the water. And also water is boiled and distilled. So there is no chance of air in the water. in this test tube B. What we are doing in test tube C, we have added anhydrous calcium chloride. So what it does is it absorbs all the moisture in the air and makes the air dry. That's why I have written dry air. So there is no water in the air, or also we have not added any of the water here. So what it is there, only the dry air is present in this test tube. Here we will see the iron nails are exposed to only water. There is no air here because we have boiled and distilled the water. There is no trace of air in the water, and the air which is in the test tube is not in contact with the nails. But in test tube A, there is presence of air and also presence of water. So after few days or few times, we will observe that the nails which are there in test tube A got rusted. So by this we will understand that both air and water are required for the rusting of iron. Both the things are very important to rust an iron nail. Students, let us see what are the different ways through which we can prevent the corrosion. Because corrosion leads to the deterioration of metal articles by converting it into their oxides, sulfides and carbonates. We don't want to lose or spoil our metal articles. That's why we have to prevent the corrosion of metals. So how can we prevent the corrosion? Either by painting, oiling, greasing, galvanizing, chrome plating and anodizing, or making alloys. See, by applying paint, oil, grease, galvanizing, chrome plating. So these are the methods in which we prevent the exposure of metal to their towards their surroundings. In the surrounding, we see there are so many elements which reacts with the metal. See what we are doing. This is a metal. This is inside metal, but outside is anything that can be a paint, oil or grease which is applied on the surroundings. By doing this, what we are doing, we are preventing the exposure of this metal to the surroundings. By that, it will not get rusted. Next thing is galvanization. It is a method in which iron and steel articles are prevented and they prevented corrosion or rusting. What we are doing in this process, we are applying a thin layer of zinc. We are applying a thin layer of zinc. See what we are doing. It is the pink color is a zinc. We are applying a thin coat of zinc on iron. So students, you have to understand, even though the zinc coat breaks, the iron articles will not rust. So I'll explain it in upcoming videos. Please to subscribe to my channel and share with your friends. Next we are studying chrome plating. So students, in galvanization we have applied only the zinc. The same way in chrome plating we are applying chromium. The process will be same for both. And next one is alloying. By making alloys we can prevent the corrosion. So what are alloys? Alloys are homogeneous mixture of two or more metals. Homogeneous means they are thoroughly mixed. Evenly, two or more metals are evenly mixed is called alloy. It may not be only the metals, we can also mix them with non-metals. Let us see few examples for that. Brass is made up of copper and zinc. Bronze is made up of mixing copper and tin. Solder is made up of mixing lead and tin. Steel is made up of iron, nickel and chromium. So one of the metal will be in more quantity, that is called base metal. See here, brass is made up of copper and zinc. So copper is the base metal. How we will prepare this alloys? We heat the base metal and it starts to melt. After that we add another alloying metals along with that and we mix thoroughly and then cool down to the room temperature. That's how we prepare the alloys. Some of the characters of the alloys are electrical conductivity and melting point of alloy is less than of a pure metal. See, brass is an alloy of copper and zinc. Bronze is an alloy of copper and tin. Let us see copper, and here also there is presence of copper. Copper has very high electrical conductivity, but brass and bronze, which are the alloys of copper, are not good conductors. So we can say that the alloys have less electrical conductivity and less melting point when compared to the pure metal. And next thing is hardness of metals is increased by alloying. So we can increase the hardness by adding them with some metals or non-metals. So metals can be hardened by adding either metal or non-metal. Let us see the example. Iron, pure iron is very soft. That's why we are adding some carbon and it becomes very hard. Next is your 22 karat gold. 24 karat, that is pure gold, is very soft. So that we are adding 22 parts of gold with 2 parts of silver or copper to get 22 karat gold. So this 22 karat gold is used for making the jewelry, and it is very hard compared to the pure 24 karat gold. So this was end of this session, students. Please, if you have any doubts, comment in the comment section. Please share the video with your friends. If you like the video, please hit a like button. Subscribe to my channel. Thank you.